we're going to extend what we have already talked about as far as instantaneous rate of change, and we're actually going to now find a derivative. And we're going to do that using limits. So it's actually exactly the same formula as we used to find the instantaneous velocity or instantaneous rate of change. And again, all this boils down to is slope. But what the derivative actually is an equation that will give us that rate of change for any point that we want. So we were finding instantaneous rate of change, but one point at a time. Now with the derivative, we can actually find the instantaneous rate of change for all points, which would be quite handy. So I have this example right here, and we want to find the derivative. Now there's lots of ways to write derivative. I could write this with a little 1 right here. And that's read f prime of x. That means the first derivative. I could also write this, d dx. That means take the derivative. So I'm going to go, it doesn't matter which one you use. I'm going to go ahead and use this one, d dx of 6x squared plus 7. And what that means is we are going to take the derivative. We're going to actually find the derivative. So what we're going to do is we're actually going to use limits in order to do that. So I'm going to find, and I'm going to actually use this one, I'm going to do the limit as h approaches 0 of f of x plus h minus f of x all over h. Now, I know what f of x is. F of x is this thing right here, 6x squared plus 7. But I need to know f of x plus h. So I'm going to take all of that and put it into here, and I'm going to have 6 times x plus h squared plus 7. I'm going to multiply that out, and I'm going to get 6x squared plus 2xh plus h squared plus 7. I'll go ahead and distribute that 6, so I get 6x squared plus 12xh plus 6h squared plus 7. So now I'm going to take that and this and put it into here. So continuing on, I'm going to have the limit as h approaches 0 of, put all of that in, 6x squared plus 12xh plus 6h squared plus 7 minus, now I need to be careful right here, parentheses 6x squared plus 7, because this is f of x, right? And then I'm all over h. Now I'm going to distribute that negative, and I'm going to note that I get negative 6x squared minus 7. So let's see what cancels right here. So I'm going to have the limit as h approaches 0, and let's start crossing some things off. This will cancel right here, and a negative 7 and a plus 7, those will cancel. So I'm left with the limit as h approaches 0 of 12xh plus 6h squared all over h. And now some h's will cancel. If I factored out an h, I could cancel these h's. And I get 12x plus 6h all over 1. H approaches 0, so now I can actually put the 0 in, and I'm going to get 12x. So I would say f prime of x, or f prime of x is 12x. That's my derivative of the function. Another way I could write that is to say dy dx is 12x. Another way, d dx of 6x squared plus 7, that equals 12x. In any case, 12x is our answer. So it's a lot of work. you got to be very, very careful. So here's an example, and these examples were from our instantaneous section. So let's take a look. Let's find f prime of x. That's what we're going to find. So in order to do that, I'm going to need f of x plus h, which means I'm going to put x plus h into here, and I'll get x squared plus 2xh plus h squared. Okay, so this is going to equal, our derivative is going to equal the limit as h approaches 0 of f of x plus h minus f of x over h. So I need to get that h to cancel somehow, some way. So this piece is right here. So equals the limit as h approaches 0 of x squared plus 2xh plus h squared minus, now got to be careful, all of this goes in here, so x squared all over h. Let's see what cancels. The x squareds are going to go away. So I have 2xh plus h squared all over h. Now, just to be clear on how I'm canceling that, in the numerator I could factor out an h, which means I could cancel those h's. So I am left with 2x plus h. And if I evaluate this limit, I put that 0 in, and I get equals 2x. So my derivative is 2x. So what could I use this for? Well, if I wanted to find what is f prime of 3, I would say that equals, well, here's my derivative, 2 times 3, which is 6. So what does this mean? That means my instantaneous rate of change at 3 is 6. And then I could find like f prime of a half. I would take that half, put it in there, and I get 2 times a half, which is 1. So the derivative is going to be very handy because I can find all those instantaneous rates of change really quick by using the formula that we get for the derivative. So let's go ahead and see here. Let's find f prime of x of this. So in order to do that, I need f of x plus h. So that's going to be the square root of x plus h. So I'm going to start finding this limit. So the limit as h approaches 0 of root x plus h minus root x all over h. Now I'm going to need to rationalize my numerator in order to get this h to cancel. So I'm going to multiply by root x plus h plus root x. Now I'm not going to actually multiply out the numerator because I'm hoping that h is going to cancel. So I'm going to have the limit as h approaches 0 of, now if I multiply out that numerator, I'm going to get, not a root, I'm going to get x plus h minus x all over h times root x plus h plus root x. So the x's are going to cancel in my numerator, and as is the h. So I have the limit as h approaches 0 of, because the x minus x, that's 0, and then the h cancels with that h after I have, actually, why don't I show that? So I have h over h root x plus h plus root x. I want to show that because you can't cancel, like on that step, you actually can't cancel it right there. You can't cancel through addition and subtraction. All right, so we have the limit as h approaches 0, and we're going to have 1 over, because this doesn't cancel to a 0, it cancels to a 1. Okay, if we put in 0, I get 1 over root x plus root x, which is 1 over 2 root x. So that is my derivative. So I would say, kind of ran out of room here, so I'll change color. F prime of x equals 1 over 2 root x or I could say dy dx equals that. So if I wanted, say, at 5, I could put in 5 right here, and get 1/2 root 5. And that gives me the instantaneous rate of change at 5 exactly. All right, let's go on. A couple more examples. So let's find this derivative. So again, to find the derivative, I'm going to need this f of x plus h. And I'm putting x plus h into here. So I'm going to get x plus h squared minus 3 times x plus h. It is a mess. So when I multiply that out, that's going to be x plus h times x plus h minus 3x minus 3. I distributed there. So I get x squared plus, I'm multiplying that out, 2xh plus h squared minus 3x minus 3. And there's nothing I can really simplify there. So I'm going to go ahead and do my limit. So the limit as h approaches 0. I'm writing this every time because that helps us to remember what the definition of derivative is. This gives us our derivative. So I'm basically saying f prime of x equals this. So equals the limit as h approaches 0. And we'll go ahead and take all of that, put it in for this. So x squared plus 2xh plus h squared minus 3x minus 3. Now, minus, be very careful with that minus. Minus all of that, because f of x is that. So here, let me show you the mistake some students might make that would cause much sadness. Go away, you. There's the mistake. Do you see it? This minus right here now is only applying to the x squared. I need parentheses right here so that this would distribute in, giving me negative x squared plus 3x. Okay, and all over h. So let's see what cancels. This will cancel right here, and plus 3x cancels right there. So we get the limit as h approaches 0 of 2xh plus h squared. That minus 3 might mess us up a little bit. Where did that come from? That should be minus 3h. That should distribute right there. So this should have an h right there. Okay, so minus 3h all over h. Okay, so now I could factor out an h in the numerator. And those will cancel. So now when I do the limit, I can take this 0 and put it into there. So that means f prime of x equals 2x. What happened? Okay, okay, minus 3. There we go. That's good. I was like, what did I write over there? That's kind of crazy. There's our answer. So this is our derivative. Now, I just want to make a really quick note right here. What does this mean? If I had a little negative right there. This means inverse. This means derivative. So make sure we keep those, distinguish those two. That's why I kind of like writing dy dx equals our derivative. And what does this even mean? This means my derivative of y with respect to x. It tells me which variable that I'm interested in. Anyways, this one. Let's go ahead and find what is f of x plus h. So if you're having trouble seeing where I'm getting this, I'm replacing that x with this. That's what I'm doing in each one of these. So now I'm going to do my limit as h approaches 0 of, and I'm not going to write it this time because my room is getting low. All over H. Okay, so now, like before when we did the instantaneous, I'm going to go ahead and combine those. I'm not going to show all the work involved with that. Basically, we need a common denominator. My common denominator is x plus h plus 2 and x plus 2. And this numerator and denominator is missing that x plus 2, so I have 3 times x plus 2 minus this one is missing this x plus h plus 2. There's my common denominator. All over h, I'm going to go ahead and remove all of this stuff right here. Let's get rid of that. And this. Okay. And now I'm going to simplify that numerator a little bit. So I get 3x plus 6 minus 3x minus 3h minus 6. What does that become? Those cancel. And those cancel, so minus 3h. So minus 3h. All over x plus h plus 2, x plus 2, all over h. Now I'm going to do this trick times 1 over h times 1 over h. Sometimes that's all you have to do to get that h to cancel, because it's going to cancel there, and then it's going to cancel right here. And now I'm ready to take my limit. I'll put that 0 in for h, and I'm going to get f prime of x. So my derivative is negative 3 all over x plus 2 times x plus 2, because h went to 0. And you could write that as x plus 2 squared. It really doesn't matter, but here's our derivative. All right, one more example. Probably the hardest of these to do is the rational ones. So let's go ahead and do one more. So right away, I'm going to find this f of x plus h. And that's going to give me 3x plus h minus 4 all over 2x plus h plus 7, which will simplify down. Okay, and now I'm going to take my limit. H approaches 0 of this minus this. So this is going to be a bear. Notice I don't evaluate the limit until I am certain that my denominator isn't just going to 0. All right, I'm going to work on this numerator a little bit over here off to the side. So let's go ahead and take a look at it. So my common denominator is going to be 2x plus 2h plus 7 and 2x plus 7. So this numerator needs this 2x plus 7. Yes, these can take a while. So minus, we're going to want to be very careful with that minus right there. So this is missing the 2x plus 2h plus 7. And we're going to multiply that all out. So let's see, 6x squared plus 6xh minus 8x, then plus 21x plus 21h minus 28. Now, that's for this product. I'm going to do this product down here. But note this minus. So I'm going to do the product first, deal with the negative last. So I'm going to get 6x squared, then 6h, xh, and then 21x. Notice I'm lining it up with this thing right here. This will be minus 8x. See, I'm just lining it up. Minus 8h. Do I have an 8h somewhere? I don't. So 8h minus, where do I want to put that? There we go. So I basically am doing this. So there is my minus 8h, and then finally minus 28. Oh, here's an 8h, minus 8h. Okay. All right, so now I had this minus, so it would be very easy to lose that. So all of these are going to switch sign. Okay, so what do I get? In my numerator, I'm going to get cancel, cancel, cancel. Cancel does not cancel. 29h all over. 2x plus 2h plus 7 times 2x plus 7. We aren't going to multiply that piece out. Okay, so all that, we got to go back. That's my numerator. So limit as h approaches 0, I have 29h all over 2x plus 2h plus 7 times 2x plus 7 all over h. I can't have that go to 0, so times 1 over h times 1 over h. Those cancel, gives me 1. That cancels, gives me 1. So I can have the limit as h approaches 0 of 29 all over 2x plus 2h plus 7. Isn't this exhausting? 2x plus 7. Hopefully you don't get lost. Be patient with yourself. Take your time. H is going to 0, so that goes away. And I have equals 29 all over 2x plus 7 squared. Now, for some reason, I actually think I have made a mistake up here. So I'm going to double check it, and I'll append this video if I did. So my f prime of x equals 29 all over 2x plus 7 squared. Unless I made a mistake over here, and if so, I'll append the video.